today's the topic is the master the fundamental of the machine learning. So before going to the deep dive, I want to tell you one story about machine learning. So the story is begun before the 66 year ago. The Arthur Samuel, the founding father, or we can say the man who has just given the definition of the machine learning first time. So once a while, Arthur Samuel went on the TV to show the world how the IBM 701. So IBM 701 was the first, so that was a kind of the computer on that time. So IBM 701 computer trying to play the checkers game. So he was interviewed on the live morning news program, sitting remotely at the 701 with Will Rogers Jr. at the TV studio, together with the checkers expert who played with the computer for about an hour. So 3 years later, in 1959, Samuel Arthur has published one study. The study name is Some Studios in the Machine Learning Using the Game of Checkers in IBM Journal of the Research and Development, containing the term machine learning first time in the era of computer. Right. So this is the first definition was coined by the Arthur Samuel, who has just coined the word machine learning. So he defined it as the programming of the digital computer to behave in a way which, if done by the human beings or the animals, would be described as involving the process of learning. So this is the first time the definition was called as the machine learning definition. So let's go for the today's agenda. So that's why this is a story coming to the picture as always. Arthur Samuel. So we called it the computer scientist. So he is the visionary who has founding this definition for the machine learning era, or we all say that he is the founding father of the machine learning. Okay, so this definition first time published in the IBM Research Journal. So that journal name is IBM Journal of Research and Development. So now, what is the today's agenda? So today's agenda is introduction to machine learning. So first of all, we trying to learn and we trying to understand that what is machine learning, how to know this is the machine learning, and why we have to use that machine learning, and what is the application of that. In second part, types of machine learning, we know that like how many types of machine learning is there, and each type is defined on basis on the different categories, something like that. And the third category, in the third agenda, we are discussing how to define any machine learning problem, which is the heart of this session. Machine learning, master the machine learning fundamentals, right? And the fourth one is like widest machine learning frameworks which are used by industry. I will just drive through that, and I will also tell you like which is more popular in the which context, which framework you can use and everything. Okay, and then after we can just go through a simple demo which you can do by your own self. So I will also give you the environment where you can just go through that, and you can do the practical as well. Okay, so let's go for the introduction. So here I already told you, Arthur Samuel is an American leader in the field of computer vision and artificial intelligence, right? So this term coined again the 1955 at IBM, and this is the name, the field of the study that gives the computer the ability to learn without being explicitly programmed. So this is the first definition made by Arthur Samuel in 1959, and that definition was used in the research on machine learning research paper, right? But then after, two more research definitions have come out. So here you can see that first definition is machine learning. So machine learning is nothing but the programming computer to optimize the performance criteria using the example of the data or the experience. Okay, so here we can say that define the some parameters and applying some learnings in execution of the program to optimize the parameter of the model using the training data and experience. So this is a bit complicated, right? So these after completing this session, you will understand this definition very clearly. right? And the last one is, you can see that the field of the study. So this is also the one definition coined by a computer scientist. So the field of the study known as machine learning is concerned with the question of how to construct computer program automatically with context of improve the experience of any system. So these are the first. So here you can see that he is Arthur Samuel, who has first time coined, and you can see that this is a checkers game, right? So this is the first time introduced in 1959. Okay, so let's go for the more detail into the machine learning, right? So machine learning was very like coined in 1959, but fast forward to 1998. Tom Mitchell. Tom Mitchell is a very famous personality, right? He is a professor and he coined the new definition of machine learning. So definition is something like a computer program is said to be learn from experience E. So let's say you have some experience, right? For particular thing. So let's say you have experience of driving the vehicle, whatever the vehicle you have. Okay, so you have that experience, right? Okay, so how you can gain that experience or how you had gained that experience, right? So with respect to some class of the task T. So let's say here I will make it simple for you. So let's say you have one task. So task is to you have to drive the vehicle. Okay, that is your task. Okay, but you don't know how to drive. Okay, so first time when you attempt it, so when you attempt it, you are performing some like first time, let's say you start your vehicle and after some covering the distance, you like your vehicle will be stopped or your vehicle will be shut down due to some reasons. Okay, so that is your performance. So basis on that, you can measure the performance P. Task is you have to drive the vehicle. Performance is how you drive that. That is your performance. Okay, so these three terms define the machine learning, but how? So let's say you have performed the task. You had just drive that for the 2 kilometers. Okay, so after driving that, after performing that task, that become your experience. Okay, so that was your first experience. Then after you had drive multiple times, and it become your experience. So getting the lot of experiences, you become expert of that thing. Okay, so that way this definition is coined by ETP, right? Experience task performance, right? So if it's performance at the task T as measured by P, so it's improve your experience E. So whenever it is improving your experiences, right, your must, so your system will learn, your subconscious system is learn like how to drive the vehicle. Same way we are coin this definition for the machine. So let's see some example is how we can just see that. Just a minute here. So this is the first example which is widely used. Okay, so this example is widely used, and over here you can see that like a handwriting recognition learning system. So here how we can categorize this handwritten, like a handwritten recognition character. So let's say we captured one photo. Okay, let's say on one paper, on blank paper, you had just wrote, you have written your name, your address, or let's say your street name, or your area name and your city name, and you had just coined the pin code. And now you want to digitalize that automatically by capturing the image, and it will automatically extract the information like zip code, primary number, or whatever that the information that you have put it on the page. So basis on that, it will automatically record that on your Excel file or on your database, something like that, right? So here, this kind of the system is we can design with the help of machine learning. But how? So here what is the task? So here task is to recognize the letters which you have written by your own hand. So you can see that we have this bounding box to over the number and over the name, or we can say street name. Okay, okay, so recognizing and classifying the handwritten word within the image is our task. Percentage of the word correctly classified. So let's say here two words is correctly classified, right? So zip code is a 14221 and here the 276. So this is perfectly classified, right? So we can say that it is give the answer in the terms of probability. Okay, so here that's my probability is needed to learn machine learning, because whenever you classify something, so classification will be measured in terms of percentage. A percentage we can calculate into 0 to 100%, or whenever we convert into the 0 to 1, it is become probability. So this way we can just measure the performance in terms of probability. Okay, now here what you have to train. So training example is like, here you have a handwritten data set. Okay, handwritten word data set. Okay, and that is already that are already classified by experts. So once you put that image, it is automatically classified and it is give the result basis on that data. So if you don't understand, don't worry, I will cover one more example. So here again the same driving example vehicle. Okay, so robot driving learning problem. So here we can see that what is the task. So this is a scenario like a robot want to drive the vehicle. So how? So let's say here the task is driving on the highway using the vision sensors. So obviously when we design any robots, we want a vision sensors inside the robot, so it can measure the distance between the each individual vehicle from the side, from the like from the left, right, ahead and below side when we drive the car, right? So same way robot is designed, and that is the task is like we have to design the robot with the vision sensors, right? So which can measure the performance and drive the car properly, like chitti robot you have seen, right? So that is a best example. So Sophia is also there, which is a very famous robot, right? So here what is the performance? So here we have to measure the performance like average distance travel before an error. So during the driving, how many percentage of the accuracy robot has carried out during the driving performance, right? So that will be measured without any error. Or if let's say robot is doing some mistakes, that is considered as error and it will try to remove in the future performance or future experiences, right? So that way. And what is the experience over here is, so here you can see that sequence of images, because what happened when robot is seeing the real world. So obviously that is a camera, which we called it a vision sensor, right? So it is generating the sequence of images, right? And robot is staying on the driving seat. So it is constantly steering with the commands recorded, okay, and observing the human drivers. He learned from the experience, like a robot is learning from the human driver experiences, right? So that way this whole TPE, task performance experience, so this definition is coined perfectly. Okay, next thing is very famous example we are just using in our day-to-day life in an email cycle, right? So let's say you have an email ID, right? And you are just able to see the lot of emails from the different like a different organizations or like that. So I want to show that as well. So let's say here you can see that this is my email ID. Okay, so this is my general email ID, where you can see that I have just I have all the different type of the emails, right? So here what is the task T? You can see that classify as a spam or not spam. So this is the task. So whenever new email comes to you, so here you can see that whenever new emails come to you, what machine learning system can do is, machine learning system is trying to identify the text or identify the image or identify the suspicious link, which is need to be classified, like this link is perfectly or not. So let's say we have a number of, let's say YouTube has sent me the mail, okay, and in that email YouTube has sent some other links as well. YouTube link is there, but two other link is there. So let's say that link are spamming something or spoofing something on our like on our email. Okay, so on that context, what happened? It is classified that first link is not a spam, but other two links is spam. So it is directly move that into the spam folder, right? So whenever it is directly move on the spam folder, it is classified as a spam. So here in the Google, you can see that they've categorized a multiple category promotion emails. Whenever you are getting the like offers or something like that, or meetups email, you can see that. So these are the social email because it is a social media email. So obviously that tags is contained like that. They're consider the email as well. This is a social community or not. So these way, like a company are gathering the data and trying to classify that like this email is a spam or not. I want to showcase you the spam email as well. You can see that. So here they are classifying that report to spam. So they are telling us is like they have moved this email to spam, but they are also asking that is this your known email? So if it is your known email, right? So if it is your known email, or let's say this is come from your trusted person, but yeah, their email is something like that is spamming. So on that context, they are just asking you as well. Report not spam, so you can just directly move on your regular folder. Okay, so these way this system is work. Now we can move into some real world applications. So like in China, right? In China, there are a lot of schools, or let's say on the street, they have just set up the lot of cameras, and they're constantly tracking the human behavior or on their faces by just camera system. So they are constantly measuring the CC. They have just set up the millions of CCTV camera on the street, on the school, on the airport, on the different public locations, and they track each and every person, so they can just observe the behavior, like who is a suspicious person, or let's say who is a robber or something like that, because they have the data set of the criminals as well, right? So in the context of any criminal activity or any fraud activity or any kind of the disastrous activity, right? Okay, on that conditions, China, not only China, but all a lot of world countries are just trying to measuring this kind of a system, right? So that system name is a face recognition. So here, face recognition system is trying to identify the human faces. Okay, trying to identify the human faces. Just a minute. So I will just put down my hands. So just okay. Okay, so guys, what happened? Like this facial expression recognition system is very popular, but it is very costly because what happened? Let's say we have a lot of let's say we have a anyone have any question you can ask, guys. Hello, ma'am, can you unmute her? Can you unmute Pramod so he or she can ask? Okay. Okay, guys, I'm not able to hear any comments, so let's continue the session. So yeah, so this is the first application of the facial expression recognition. So uses of this application is to monitor the human behavior, monitor the people. So on the some street, let's say any criminal who are just away from the, who are just let's say just break the jail and go outside. On that context, this kind of the system is helping us to identify that kind of the human being who are that kind of the robots, or we can say that kind of the assassinated human beings who are just constantly making that kind of activity on the streets. Okay, so this system is even this kind of a system is using for measuring the attendance in the school. Okay, automatic attendance system, right, with the help of your face. So basis on the face, we are also identify that, like on the bus stand, you can see that sometime, let's say facial expression recognition system help you out to just open the door if your face is registered on their system, that way. So this application is very generalized application used worldwide. Okay, so here what is the input? So input is your image, your face image, and on that face image, we have to just put the bounding box, right? So here the square box you are able to see, right? That is known as a bounding box. Okay, and what is the output of that? Output is the probability of your persons of interest. Is like, let's say I'm so they detect me on this phase, right? And the predicted probability is like 85%. 85% Ashish Patel is detected. Okay, so on that context, this is showcasing this kind of the box, and the probability outside that is like 85% is Ashish Patel, right? This way, so 85% is accuracy, or we can say that persons of interest. So persons of interest is nothing but the persons of interest is basically known as probability of particular human being is detected on that. Okay, who want to ask the question? Ashish Kumar Pal. Yes, Ashish. Yes, Ashish. Yes, Ashish. Can you ask? Okay, maybe. Yeah, so another application you can see that it is using the text to speech application, not speak to text application as right. So let's say you are whatever you are speaking, it is automatically converted into the text. So nowadays, why like a popular, I can say popular tool like that we are able to see in the market. I want to showcase you the real world tools. So that tool is known as Alexa and Google Home. Alexa and the Google Home, right? You can see that these two tools are the very famous tool in the market, right? So Alexa has its own ability, Google Home its own ability, and parallelly with they are understand the multiple languages. So when the time goes, they are getting the more maturity in the knowledge, in the language context, and lot of things, right? So whenever you see this kind of the device, and whenever you can see the performance of this device on the YouTube, you are able to see that like what, like how many types of the ability they have. So in Google Home, they have a system, speak to text system, that is known as a Google Assistant, right? That is a digital system. Same Alexa have Amazon Alexa, which is similar like a Google Home or Google Assistant system, which we like which are assisting you, right? Assisting you to, let's say you are speaking, let Alexa open the light or start the light. So they start the light. Just you are telling the Alexa, please start the music. So Alexa will start the music, something like that, right? So this is the example. So same thing, you are able to see like what is the input of this. So input is our wave signal, whatever you are speaking, that is known as an input signal. Okay, so you can see that whenever I will tell you, input output is always we have to give to them, right? So input is a speech waveform and output is actual word, what you have spoken already. Okay, so these are the system, and I had already given the real world example. Okay, you can play around it. Third is a very famous application is a self-customizing program, right? So Netflix, Amazon Prime, then we have a Z and lot of OTT platforms, right? So every OTT platform is a give you every OTT platform want to give you the personalized experience. So personalized experience is something like, let's say whenever you are just whenever first time you are going on the Netflix or Amazon, or let's say you are going, you are logging with some new numbers or from new email IDs. They're asking you which language you want to prefer. So we are choosing our home languages, right? Home language, let's say I am from Gujarat, so I choose Gujarati, then after Hindi, national language, then after English. So they are trying to personalize my experience basis on that. Okay. Then after they're asking you like on which category you are interested the most. Okay, so on basis, so let's say I choose a documentaries, I choose a science fiction movie, I choose a cartoons, right? And I choose also the athlete movies or sports movies. So these are my personal choices, which let's say I choose on the Netflix. So what happened? Netflix will recommending me next time the top movies which is highly rated and their feedback are positive and they are just predict the probabilities. This is the prediction basis on your interest. So that is known as a recommendation system. So for that, which type of the input data, let's say you want to design this kind of system. So for that, we need input data. So input data is like movie watched, like how many people have watched a particular movie, then how many average rating this movie are getting, okay, and rated positively or rated negatively. That kind of also classifications we have to given to the system. So system will trying to understand, and basis on that they are recommending the top movies to the new watchers, or we can say new users who are coming on that platform. Okay, so these are the generalized applications we are able to see. Right, till now we have seen that what is the machine learning, what is the applications, how applications are coined, and what is the real world applications of that. Right, now let's see types of machine learning. So here you can see that one word, taxonomy. So taxonomy, what is the taxonomy? So taxonomy is nothing but subtypes of machine learning. Okay, so here you can see that the machine learning is basically classified into the three categories: supervised learning, unsupervised learning, and reinforcement learning. So before going into the deep, what is the supervised learning, what is unsupervised learning, and what is the reinforcement learning, I want to tell you one thing. So basically what happened, machine learning is very vast, but this is a three major category which we are classifying the machine learning. But nowadays there are a lot of type of the learning is there. There is a active learning, there is a reinforcement, there is a imitation learning. There are a lot of, okay, there is a transfer learning, there is a contrastive learning, and lot of type of transducive learning, and lot of type of learning is there. But yes, this is the three basic category which is machine learning classified. And what category I had just explained you, that are the categorized under these three. Okay, basically under these three, and others are categorized under the artificial intelligence. Right, so I will also discuss with you that as well. Okay, so what is the supervised learning? So here you can see that two words, regression and classification. So yeah, in real world, or let's say the people who already know about this is like what is a regression and classification. So let's make it simple. So supervised learning is something like, let's say you have some data, okay, and that data you want to just you want to just understand. So let me open one data. So let me download one data from the Google, so you can just see live. So let's go on the Kaggle. So Kaggle is the home of machine learning. Okay, so here you are able to see the data set. Okay, so every data set contain the most of the CSV file. So I will take this lung cancer prediction data set, you can see over here, and you are able to find the data over here. So that is nothing but the one excel file. You can see that this is a column of that data. Okay, so let's say we have a medical data. Okay, these are the lung cancer prediction. Obviously, this data observed by the medical doctors. So medical doctors is known as SME, subject matter expert, or we can say that are the medicine experts. Medicine expert, or we can say the medical scientist who are gathering that data, and basis on their observations, they are trying to prepare this kind of data set. So obviously, we call them a supervisor who are supervise this data. Supervise means under some specific conditions, they are trying to generating the data. Okay, they are generating the data. Okay, so you are able to see this is our data. So let me download this so you are able to see clearly. Okay, so this is our Excel file. Okay, and this kind of the data is observed by the doctors. right, under some medical conditions with the help of some machines, right, medical machines. So here you can see that this is a patient ID, age, gender, air pollution, alcohol use, dust allergies. Let's say someone have a dust allergy. So these are the features, or we can say these are the main categories that doctor want to identify. Let's say someone is smoking or not, someone has obesity or not, someone has a balanced diet or not, right, chronological lung disease or have or not. So they are trying to calculate this all with the help of machine, and they are just putting some numbers. So number is represent some categories. So let's say 3. So 3 is like severe, they have a severe swelling, like a swallowing difficulty or not, something like that, right? So number is measuring the highest to lowest severity, right? So this way we are just identifying like how many category doctor is taking to observe some medical disease. So let's say here we have a almost 25 columns, okay, and 26 column is they have a lung, like, okay, so they are measuring the severity of the they have a lung cancer or not. Okay, so here you can see that they have a low lung cancer prediction, they have a medium lung cancer prediction. So here you can see that patient ID to the target. So this kind of the data set is using to understand the supervised behavior of any patient. Okay, so let's go on the presentation again. Okay, so here you can see that this is a kind of the category is known as a supervised learning category, where you have a target output. Okay, so target output is something like I want to showcase you in just a minute. So target is something like doctor has already observed these conditions, right? So let's say doctor have observed these all the conditions, basis on that they have decided like a patient one have a low chance of lung cancers, this is a medium chance, high chance, right? So here you can see that whenever we have these observe kind of the variables, right? So these observe variables is basically known as the
Sir,
classifier.
sorry for the interruption. Someone is telling like your data is not visible. Only
Data is
the yeah.
screen is visible. Just a minute. Let me see the full screen. Just a minute. Okay. Are you able to see now, browser?
Yes.
Now the data is visible. Hello.
Yes, so now it's visible.
Okay. So yes, guys. So this is basically the lung cancer data set. Like doctor is trying to measure the like some patients have a lung cancer, or like their severity, like they have a low severity, medium or high chances of severity, right? So basis on that, this data set has been prepared by the super expert, right? So here you can see that they have trying to identify this pattern. Okay, so this pattern you can say, let's say any type of the pattern they have observed. So let's say this patient have a different type of the high, right? So this has a high chance, this has a low chance, and let's say this is a medium chance. Okay, so doctor has categorized these lung cancer prediction in the 3 category: low, medium, and high. Okay, so basis on that, doctor has prepared the data manually. Okay, so once this kind of the data is prepared, they also prepared the final results, right? So let's say this kind of the pattern contain the low severity, medium severity, and high severity. So these labels are given by the doctors. Okay, so whenever we are discussing about any kind of the problem on supervised learning, we always have this kind of the target output, which is observed by the expert. Okay, so here this column, like whatever the column is known as the feature in machine learning. So just coin this word, feature is nothing but the columns. Okay, and that feature is known as a x, big X, right? So I can say that this is a big X, something like that. This is a big X and this is a Y, right? And basis on that formula is come, y is equal to mx, or we can say wx plus D. Okay, so X is your all the columns and Y is nothing but your target column. So basis on that, we are preparing this W. Okay, so this W is nothing but the machine learning mind. Okay, so by training any machine learning algorithm, we are preparing this W, and that is known as the machine mind. We call it a model in machine learning. Okay, and this B is bias. Bias is like your error. Sometimes this error is considered as assumptions we had taken during the measuring the data or something like that, right? So this way any data is coming. Okay, so this first category which I had just consider is known as a supervised learning. So whenever you have this target column, right, target means Y, and this is your X. Okay, so whenever you have X and Y both, right? Okay, so X is whenever you have a feature, and Y means your target. So whenever you have a feature as well as a target, that kind of problem is known as a supervised learning problem, because that are supervised by some experts. Okay, so that's why it is called supervised learning problem. Okay, let's say I will hide this. Okay, doctor have this pattern, but doctor don't know what is this severity is called. Okay, low, medium or high. We have only X, right? Now you can see that we have only the X. We have these only X. Okay, these all are the column known as X. Okay, so we have these only X, and now, okay, we have only these X, and now what we have to do? We have to identify the severity, what you are doing. So here the condition to observe the things is like, we have to just measure the similar groups. So let's say these kind of the groups, let's say this is one, this is the second category, this is the second category, this is the third category, right? So let's say from 100, 30 samples are considered as consider the similar pattern. Okay, so let's say you have a one class. Okay, now you do like I will tell you that basis on the student marks or in between the student marks range, you have to just make the group. So what you are doing, you are just defining the indices, let's say from 1 to 30, 30 to 60 and 60 to 100, and you are classified that group is like 1 to 30 and 30 to 50, 60 and 60 to 100. Basis on that, so these data don't have that target, right? These data consider only the this kind of the feature, but they don't have the supervised observations, right? So this problem is identified in the when any company, let's say Netflix kind of the company, want to personalize your experience on the first time. Obvious, so they don't have this kind of the event data, so they are asking you. So let's say they are asking you which language you are preferred. So let's say Hindi, then after Gujarati, then after let's say English, or let's say Marathi, or whatever the language. So let's say they have chosen the 5 languages, and then after they have chosen their area of interest. So let's say sports, a movie, documentaries, like a romantic movie, or whatever the category that is. So basis on that, they are trying to generate one pattern. Obvious. So there may be a chance there are multiple users who have the same pattern, and these users, let's say 5 and 6 users, are already seen the lot of movies. Okay, so they have just seen these type of the movies. Okay, and this first user is coming. Okay, after some time, after 5 to 6 has already watched more than, let's say, 10 movies. Okay, and the new user is coming, user one. Okay, and that user has contain the same category like the 5 6 user. Okay, so when pattern is matching, they are just predicting the same result that 5 and 6 has just already watched, right? So they are just put these user into their category, and basis on their interest, basis on the previous user, they are recommending you the next movie. Okay, so this way, like recommendation system is working at Netflix, Ghana.com, Spotify, all are using this kind of the system, and these is categorized under the clustering, or we can say that unsupervised learning, or we can say that association rule mining. These all are the category belonging under the unsupervised learning. Okay, and third category is a reinforcement learning. So let me close this. So reinforcement learning is a different kind of thing. So reinforcement learning is just imaging, like in your house, or let's say in your house, or like in your like in your neighbor, you can find some small childs, right? So that small childs are learning in the way that they are just see their parents or see other people's like how they are behaving, and basis on that they are just they are constantly monitor the people, and basis on that they are trying to learn, right? So they are just trying to learn something. So let's say first time any child started walking. Okay, where is the pen? Okay, so let's say there is one child, okay, who want to start learning. Okay, so he has taken a first step, okay, but he fall down. Then he stand up again, he take a second step, then he fall down again, then he has taken the third step, then he fall down, then he's trying to observe other people. So let's say he has his parent who are encouraging him stand up and walk, right? Or trying to give some rewards. Okay, so here you can see that he is trying to attempt, then he will get fail, and his parent is giving his reward. Come on, you can do it, you can do it, on that way, right? So same way reinforcement system learning. So action and reward method. Whatever the action you are taking, and let's say you are not getting success that time, so whenever you fail, you are punished. Whenever you are doing a good, you are getting the reward. That way action and reward method reinforcement learning is working. So basically, not spending too much time over here, and let's go to the major section on this. You want to ask the question? So here I am coined the word numbers. Okay, especially the number. Okay, so whenever we are coined the word number, so this is basically relevant to the number prediction. So let's say house price, right? So house price is obviously we are just predicting in the terms of number. Process optimization, that is also in the number. Let's say what is your stock price, how much it will increase or decrease. Or let's say new insights coming into the market. It's like, let's say how much it increasing or how much it decreasing for the next 10 years, something like that. Real estate market, economical boom, or whatever. So it is regression is using it the number of industry. Okay, same way, classification. So whenever you want to predict some categories like, let's say this is a cat or this is a dog, you want to take this product or not, this customer will retain or not after this buying, what happening in the machine is good condition or bad condition, what the image is like cat or dog, something kind, is the fraud happening or not. So something kind of categorize, we can categorize this category into the different domains, right? So classification and declarations. So these are the different domains: the dimensionality, reduction, clustering. So I showcase you the example of recommendation system, right? Target marketing, right? So customer segmentation. So whenever we don't know about the customer pattern, we are segmentized basis on their uses of the money. So let's say this customer buying every month this much of average amount, this customer is buying this much of average amount, something like that. Target marketing is like, let's say you are see something on Amazon, they are showcasing the ad everywhere. Okay, whenever you are going, they are showcasing that advertised everywhere, right? So that is known as a target marketing. Recommendation system is also there, right? So dimensionality reduction is also the similar kind of category where you have to deal with the big data. So billions of and millions of customers is there. Let's say Facebook has a billions of users and they want to scale up their data. So on that context, you have to deal with the big data, right? And from that data, how much data is only useful. So for that, they have to reduce the number of data. Is like how much data is useful for the particular insights. Basis on that, then we can also do the structure discovery. We can also do the feature eliminate elicitations. So these are the kind of the domain like structure discovery and all. So these are the kind of the domain where machine learning is used. So machine learning used in wide domain of varieties, right? You can see that gaming, reinforcement learning used to train your game. Okay, so game programming is very interesting. Everyone, everyone want to set up the games and play on their machines. But let's say machine is playing with their expert level of knowledge with you. Are you able to beat the machines? So these kind of interesting things come into the picture. Real-time decision making. So let's say traveling salesman problem. So one interesting problem is let's say one company who want to deliver their products in supply chain management, but they want to define the route so they can travel the least distance and on least time. So these kind of the problems come into the real time decision making, right? That is also coming to the picture. Learning task, automatic learning task. I told you like a child or you are training the robot something. So robotics is coming to the learning task. Skill acquisitions, like what skill you have to grab or what skill you don't have to grab from the uh, time to time something, and robotic navigations, right? Like drone and all are using this robotic navigations. So these are the big picture which I wanted to showcase you. That's why I take more time over here. Okay, let me erase this all and move on the next slide. Okay, let's move on the next slide. So you are able to see how regression works. Just yeah. So let's say this is your input data set, right? Label data set prepared by the expert. So let's say by seeing the cat, we are just label that this is a cat. By seeing this is a mini cat and this is a big cat. So we classify that and we are just give that images to the machine. What machine can do? Machine is trying to extract that knowledge and machine will understand. So you can see that they have machine has understand this knowledge and converted into the green color. So machine has already grabbed the knowledge. Okay, now let's say new machine will understand like what is the cat and what is the dog. So what happening over here is like machine is trying to understand the shape from the images. So how machine understand the image? Machine is converting the image into from image to matrix, right? Mathematical matrix. So it's a mathematical word, right? Matrix is very famous. So you can see that like it's prepare something like that. This is a matrix. Okay. So let's say here I will draw the cat. Okay. My cat is different one than this. Okay, this is bit weird cat. Okay, so this is the cat. Okay, and here let's say this is a background. Okay, this is only the cat and this is the background. So machine is seeing this image like this. Wherever the background, let's say there is no background, so it is consider no background is a 0, and wherever the image is there we will put the 1. Okay, so where the image is there it's put the 1. Okay, so that is known as a region of interest. Something like that, right? So wherever you are seeing that these lines and all, machine will put that color as a something intensity value, or here I want to just demonstrate, so that's why I use 0 and 1 matrix. We will complete, then here over 0 you are getting the 0, right? Background. So image is converted into the matrix, something like that. Okay, but there is some RGBs value, red, green and blue value, and you will able to see like how machine is working. So this way images classify and images regressing that. Okay, so this is a supervised learning flow, like how supervised learning work. I will showcase you the demo as well, guys. So let's move the quickly. Okay, so on the next slide, you can see the same thing, but you can see now we don't have the labels here. They are trying to categorize. So here we have a two type of the color. Let's say dog contain the green color, okay, and cat contain the orange color with a different shape. You can see that cat face shape is a round, dog shape is a not a round, right? It is a kind of ellipse, right? Different type of shapes we can say. So you can see that dog has a big ear than bigger, right, as compared to cat. So when machine is trying to understand, machine is trying to understand the shape of the your object which is lying in the image on the particular point. So let's say here cat contain the round and like dog contain the biggest, right? So we can, whenever we classified, you can see that machine will classify into the different groups with the color, shape, taste, or something like that, right? So these are the examples. So here you can see that. So basically, these are classified into the two category, like a supervised learning into the classification and regressions, right? So classification is only come when your label is a category, but whenever your label is a number, let's say weight prediction, or let's say what is the price of price prediction, so that time your problem is a kind of regression problem. Okay, here grouping you are doing, so your problem here, you can see that in clustering they are grouping with the colors. So this is a similar group, they are trying to gather the samples, and they are make one form of the group, that is known as a clustering. And anomaly, so anomaly is something like in intruders behavior. Intruders behavior is something like they're behaving abnormally. So I will give you the example. So let's say from 21 to 30 age people, average salary is 65,000. Okay, this is just an example. But let's say there are a superstar, Bollywood superstar is there, Hollywood superstar is there, or let's say some famous people who has a higher income compared to this, right? Compared to average salary. So obviously they are considered as outliers because their salary is 10 time or 20 time or 30 time or 100 time higher than average salary. So that's why they are considered as abnormal persons, or abnormal, or you can say the special type of the category. So we called it the anomalies or outliers. Okay. Now reinforcement learning, as I already told you how reinforcement learning works. So reinforcement learning is trying to understand, like this is, let's say this is a fire, this is a water. So they are trying to touch. Okay, when they are trying to touch, like a robot get hurt because they just put your hands on the fire. Okay, so fire will give you the penalty, right? Because you have to identify water drops. So whenever you are just click on the, whenever your robot is trying to identify, okay, this is a water, so it will get the punishment like 50 point minus. But when we will train that this is not a fire, right? So we will tell them is like your decision, you learning the bad decision. Okay, so whenever we are giving the bad decision, it is trying to iterate the process. Next time it will not touch here because it is already punished by 50 points. So next time it will try again and trying to understand water drops. Whenever it the water drops, we will give you the good, and it will iterate the process 1,000 times or 10,000 times. So it will understand. So by 10,000 type of iteration means we are giving the 10,000 type of experience to them. Okay, so here the task is to identify which is the water drops and which is the fire, right? So the task is that, then after this is performing, so that is known as the action. So action is nothing but the performance, and then after result is your final output is like bad, this is bad experience or good experience, and it will constantly iterate. So it's like a life experience what we are taking in our day-to-day life. Okay, now what is the machine learning life cycle? Okay, so guys, you can see that machine learning life cycle. I will quickly go through this brief. So let's say you have a data. Okay, your let's say you have a data, cat data, dog data, or whatever the type of data you have. Let's say I already showcased you the Excel file. That data is come to you. What is the first step of the data science? You have to understand the data. You have to explore the data. So how you can explore that? During the exploration, you have to draw the graphs. Like you have to draw the bar graph, pie chart. Then there are a lot of types of the graph you have to use. Okay, and then after you have to understand, you have to do the univariate analysis in exploration analysis, you have to do the bivariate analysis, you have to do the multivariate analysis, and try to understand the pattern is like which variable or which like which category, or we can say that which feature is impacting the more on the target. Impacting more on the target means like basis on the some feature, obviously that product become good. So let's say Google Voice Assistant. Why Google Voice Assistant is beautiful? Because we are giving them a speed to text technology, or we are giving them a speed to text, like we can say the assistant, right? Like which is known as an NLP system, right? So which is very beautiful, so that make the machine more robust, more interactive, and more powerful, so it can handle the our voice command, right? So that way, that feature is impacting on the target output. So that type of we have to understand the exploration. Once you understand the data and you understand validate that data, you are trying to cleaning that as well. So let's say in some category some data is not useful, or let's say by taking that data some missing values are filled or some values are not filled with that at all, right? So in that context, that is known as a wrangling. Wrangling second name is a cleaning. Data cleaning or data wrangling are the same operations. Okay, once your data is wrangled or let's say cleaned and statistically analyzed, you are splitting that data into the two versions. Okay, one on training set, one on testing set. Why we are doing that? For why we are doing that? So means our supervisor has already provided us the supervised data. Okay, so that's why we want to some time of validation data as well to check the performance of the model. Okay, so in that context, what we are doing is we are just split that data one on the, so standard splitting ratio is 80-20. This is on the Pareto principle, right? This is a management principle. You can check like your 20%, your 80% data is giving you the 20% result, or your 20% data is giving you the 80% result. That is a kind of the philosophy behind this principle, management principle, but that are applicable over here is that. So train and test is like we are split on 80-20 principles, right? And we are training that 80% data. We are training this 80% data. Okay, and we are we are we are checking the performance of that model on this test. Okay, which is a 20% of the data. Okay, once we analyze this data, we are putting that model over here, right? Because obviously we know that not a single model will performing good. Okay, so that's why we are applying the multiple algorithm, right? Decision tree. So there are 100% algorithm in machine learning. Okay, so we don't know how to apply that, which algorithm is performing good. Okay, we know that how to apply, but we don't know which algorithm is performing good. So that term is known as a no free hunch. Okay, for that you have to do the experiment. Okay, and whenever you want to do the experiment, you have to train the algorithm 1, algorithm 2, or multiple, right? Let's say 10 algorithm you are trying to train. So for that algorithm, you also do the model versioning, like, and you have to check the performance. Like after training the 10 algorithm, which model is working good. So let's say from algorithm 1 is a decision tree, and you want to train that decision tree algorithm, and that is performing good in applying the 10 algorithms, right? So you are just using that algorithm, you are trying to deploy that. Deployment is like you are putting that into the real world application. So whatever your user is, they are using that. Okay, but let's say this model is we are deploying. So how you can deploy? So for deployment purpose, we are using the DevOps system. DevOps is nothing but the development operations. Development operations is known as a production engineering, where we have to put our machine learning model. So we are putting that model on the Docker, or we can say that Kubernetes kind of service. So Docker is a kind of service which will take your model and try to host on the server machine. Okay, or it's create a new service for you. So once your model is ready, we are deploying that on the like your model is putting on the production side, right? Once we will provide the green signal. But let's say after 6 months or 10 months, your model is not performing good. Okay, so what happened? We are constantly monitoring that model. Is like, let's say new data is coming every day. So your model is performing good, but after some time, let's say after 6 months, your model is performing bad. So we are iterating this process again and again. Okay, and how you decide decision tree model is good? So for that, we are using a model evaluation. So let's say you have a classification problem. We are using accuracy, precision, recall, F1 score kind of things. But let's say your decision tree is already in the deployment. Now you want to increase the performance. So for that time, you are using this kind of the tech that is known as a feature engineering. Feature engineering is like you are adding the new features or a new column or new specifications of the current scenarios, which will improve your data performance, and data performance improves your model performance. And you are applying some hyperparameter tuning. like you are training more time. Let's say first time you had already trained for the 100, but let's say you want to train for more 100 epoch, or you want to just change the learning rate or something like that, right? So that way it's improve your performance. Okay, and by the time constantly you have to track the model performance, right? So you have to constantly versioning your data, versioning your code, your data, your model, everything. So this is a modern 21st century modern machine learning life cycle. This is not an old life cycle that used in the 2020 or 2019. This is the latest, including the MLOps, right? Machine learning operations. So this is a kind of life cycle, right? Which is including the software code pipeline as well. So so this is the machine learning life cycle. So let me go through some canvases. How you can design any machine learning product. Okay, so let me quickly go through that. So these are the canvases. These are the canvases like how you can just define any task. So you have to ask the question like what you want to solve first. So what task or decision you are trying to examine. So let's say I have an images. One image contain the cat, one image contain the dog. So I want to examine like in the image, this is a cat or a dog. Okay, so this is my task. So this is known as a product canvas, right? You can design your machine learning product by just analyzing these questions. So I will provide you this PPT to you, so you will get this. You will get this canvas, or you can observe this website as well, right? So let's say you try to just define your task. So prediction, like what you want to predict, identify the key uncertainty that you would like to resolve. Okay, so identify the uncertainties, like because what happened, you have some cats contain the face like a dog. Okay, because their hair are the same and something similar property they have. Okay, so whenever we are trying to say there, what kind of the uncertainty you are able to find on that, so that is your prediction. Okay, now which kind of the judgment you want to take. So judgment is determine the payoff to being a right versus being a wrong, right? So like let's say your model is predicting cat to dog. Okay, so that is a false positive result. Okay, or we can say false negative result is there. So is that result correct or not? So we have to identify why it is giving the negative result. So that kind of the, because yeah, obviously that data is wrongly categorized or wrongly labeled. That's why this judgment is coming. So what are the actions that you would be choose for particular errors? Okay, so basis on that, your algorithm will be performed and what outcome you are getting. So we have to choose the performance matrices. So here I told you, right? Performance matrices for regression, for classification, you can use accuracy, precision, recall. You can also decide which matrices you want to use based on your need. Okay. Then after training, so like you can decide like how much epoch you want to train or how much input data you want to get. So let's say you have 1 lakh row and you want to train that. So you are training the 80,000 rows and 20,000 rows you are used for the testing purpose, right? So that things we can use for the training input way, right? So like different algorithm is taking the input on the different way. Okay, so that's why you have to careful like what data do you need to generate the prediction, right? You have to be very careful like which column is only important. So let's say you have a 25 column, but not all the column is useful, only 5 to 10 column is useful. So you have to choose which column is useful and how algorithm wants, like you have to provide that data in the form of how algorithm is accepted that. Let's say some algorithm accept array, some algorithm may accept a tabular format or basis on their need, right? So that is known as a data structure. Like you have to understand the data structure, which kind of the data structure algorithm is accepting. That kind of data structure format you have to convert from your Excel file to that data format, and you have to constantly take the feedback of the model is like by doing the testing of the model, and you will define that how will this AI impact on your overall workflow. Okay, so let's move on the machine learning canvas. That was the AI canvas. This is the machine learning canvas. Machine learning canvas is basically help you out to design a whole data science product. So here, let's say you want which kind of the prediction you want to do. So prediction task is a classification, which kind of the input data, input object. So let's say you have an image. Okay, so you have some output prediction. Output is your label or you can sometimes we take output as an image as well, right? But that was a very advanced concept. I will not explain you over here, right? Now decision, like which kind of the decision you want to take. So decision is a process for tuning the prediction into the proposed value. So let's say you want a decision in the probability, so it will give you the answer in the probability, or you want in the label of that will also we have to transform basis on the need. Okay, value propositions. So we have to identify what this task will add the value to the end user. So end user will get automatically identified like which is a cat image or which is a dog image. Okay, or let's say for the fashion industry, which kind of clothes is this? Or let's say identify the category of the fabric. Okay, we can. So these are the objectives. Like so, we have to define that which are the objectives our task will say like serving to the end user. This is on that we have to do. Then after sometime what happened, you have to collect the correct data, right? So for that we have to define the strategy, which kind of the data you want for the training purpose, what is the output acquisition cost, what is the continuous update rate of that data, what is the holdout ratio for your input data as well. Okay, and then after you have to understand the data sources. Let's say you are collecting the data, but you have also have to know that this data is coming from the cloud, this data is coming from the sensor. That way you have to identify the data sources, either it is from internal or external, right? And you have to understand that meta dictionaries as well, right? So these are the data sources we have to identify constantly. Then offline evaluation. So offline evaluation is sometimes known as a test data evaluation, right? Test data is like we have already seen over here, right? So once we train the model, we are evaluate the model on the by using the different matrices. So that's why they are telling that. So offline evaluation is nothing but we have to check that like this model is performing good, this model is performing on the fair values or not, something like that. Okay, now time to making the prediction. So we can check that like our model is working on the batch predictions. So let's say you have a 30,000 of data and your model is predicting on at the same time. So yeah, you can say that your model is handling that 30,000 batch data at the same time, or real world data as well. Also we also have to also have to featureization that, and we have to also have to do the post processing, because what happened, whatever the pre-processing we are doing on the train data, the same pre-processing we have to do on the test data as well. Okay, and the computing the target is like nothing but the what the target prediction we can say that like how much data computation data we have, and basis on that machine will take a computations of that. Let's say it should take a let's say 30,000 rows, so let's say it's a 5 MB 10 MB something kind of the data, and how much computation will take. So whenever you give the more data, it will take a more computation that you have to measure in the time. So that is known as a time complexity. Okay, now building the model. So building the model is nothing but different algorithm you are training on your machine by taking the input data. Feature is I told you already in the lung cancer prediction data set, right? Feature is nothing but the column which is contain the different kind of the specifications. Okay, live monitoring. Live monitoring is like, let's say you trained already your data, but you also want to see how model is performing on the graph. So you can also apply some matrices. Okay, like a precision recall, F1 score, and similar kind of. So this is a canvas help you out to design the machine learning flow. Okay, now based frameworks which is used in the programming. So you can see that like 7 frameworks which is widely popular in the market. So I want to showcase you lively. So here you can see the pandas, right? So let me type pandas. You can see. So this is a nothing but the SQL type, or let's say Excel type of library. So these all libraries supporting Python, not R programming, but for R they have a different libraries, right? So I am not covering R over here. I will covering the pandas library one. So you can see that pandas library is basically used for the data analysis. Data analysis is like you want to perform, let's say, some grouping, some merge operations. You want to discard some columns. You want to add something inside that data. You want to apply some statistical operations. You want to just separate some columns and you want to analyze that. You want to plot the graph and everything. So pandas is helping you out. Okay, so this is the first library. Second one is a NumPy. So NumPy full form is a numeric Python. So numeric Python basically help you out to just calculate the two things. Statistic you can do, like all the type of statistical operation you can do with this. You can do the signal processing operations as well. You can just measure the signal. You can calculate the fast Fourier transformation. Similarly, NumPy is also providing the linear algebra operations as well. Right? You can calculate the matrix multiplications. You can do the different kind of operations with the help of that. Right? But you can see over here, these are the supporting with the different scientific domains. Right, scientific domains is like quantum computing, statistic computing, signal processing. Even it's used in image analysis, using graph and network. Astronomy analysis is like in the like astrophysics are used. It is used in the brain psychology, or we can say the cognitive psychology as well. It is used in bioinformatics, Bayesian inference, mathematical analysis, chemistry, geoscience, earth engineering, geographic processing, architecture, and engineering. So these are supporting wide variety of domain. Okay, so that's why this is very famous. Here you can see the data science. When you click on the data science, you can get the different kind of the right. So NumPy is very popular for the mathematical operations. Basically, in one line you can say that it's very popular in mathematical operations. Right. Third one is a matplotlib. Okay, matplotlib is also a very popular library to draw the graph. Okay, so when you want to deal with, you can learn everything over here as well, right? So you can see that when you click on the plot types, you can see different type of graph is there. So these library are integrating each other, right? You can use a matplotlib with the panda, matplotlib with the numpy, and you can use a cross integration as well in the code. Okay, so you can just plot this kind of the graph. Okay, so these are the different graph that you can use for designing your plots. Exploration data analysis, I already told you, right? Third library is a scikit-learn, right? Scikit-learn is a machine learning library where scikit-learn serving famous. So scikit-learn is serving all the type of algorithms. Okay, so when you want to see the algorithms, I will showcase you API. So you can see that this is a there are a different kind of algorithms you are able to see. So there are more than 100, 200 algorithms in machine learning, right? So let's say you want to see the linear regression. So you have to go on a sklearn linear models. You can see that this is a linear model. So here it is supporting the linear regression, logistic regression, right? Then it is support the ridge. So these are the different algorithms. Regression algorithm. Regression means you want to predict the house prices, you want to predict some prices, you want to predict some weather prediction data. Let's say what is the temperature of today. So that time these kind of algorithms helping you to use it. So this library is known as a scikit-learn, very famous library in the all scientific domains. Okay, third one is a TensorFlow. So TensorFlow is a similar library of machine learning, but TensorFlow is basically used for the neural network, which is an advanced version of artificial machine learning. So machine learning advanced version is known as a deep learning. Okay, deep learning. So it is starting from the neural network to all the advanced versions. So nowadays you can hear the sentences like when you type the text, it is generate the image. When you type the text, it is generate the music. When you just provide the image, it is generate the background music for the same image. So that kind of the things is come under the neural network design and a deep learning based approach, right? So this is an advanced mathematical library that is known as a tensor algebra. Right, like a linear algebra, we have a tensor algebra when you are dealing with a 3D data. Okay, so that time this library TensorFlow is helping out. Keras is a similar library like a TensorFlow, but Keras is like more easier than TensorFlow. Okay, it is also deal with the artificial neural network kind of design and all. And PyTorch. So TensorFlow and Keras is designed by the Google, and PyTorch is a similar library for the deep learning, but it is designed by Facebook, Meta AI. Okay, so these are the basic introduction of the Python frameworks. So I am not going through on lot of detail, and I will open just a minute. just open one Jupyter notebook. So like we have a time constraint. So I will just open one Jupyter notebook where I will showcase you the quickly. I will showcase you the just a minute. Let me open. Right, so now I want to showcase you the hands-on experience, right? So here you can see that this is a Jupyter notebook. Okay, so this is nothing but the directly available environment which you can use, and you can just directly utilize this environment for your learning purpose. Okay, so I want to just showcase you one demonstration of the example. So let me upload one Jupyter notebooks. So this is basically the Python environment. Okay, Jupyter Python environment where you can able to do the Python programming. So let's say you want to print your name. Okay, you have to just give RC. Okay, and we have to run that. So for running this cell, you have to use a shortcut key shift enter. Okay, and it will execute. So when you do it, it will automatically connect your online computer. This is provided by Google. Okay, this is known as a collaborative Google collaborative open environment. So this is also known as a Jupyter notebook. Okay, and by using that, you can see now now it's connected. Now it is printing Ashish Patel. You can do the calculator operation over here. You can do the mathematical operation like multiplications kind of operation over here. So I will not just give you the example of going into the brief, but I will upload one notebook from my desktop. Okay, so this will open the new Jupyter notebook, which is a decision tree based one patient data. Right, so here this is our patient data notebook. Right, so this is a PIMA data set. I will showcase you within a 15 minutes, guys. I will not take a lot of time. So here you can see that this is a data set observed by. So this is a data set observed by or gathered by the National Institute of Diabetes and Digestive and Kidney Disease, right? So this is an organization which is collecting this data. Okay, so the content of this data set. Is nothing but like we observe the patients. Okay, so patient have a diabetes or not, that is a target outcome, right? And for that observations, they are observing the different kind of the outcomes columns, right? So here I can showcase you like a number of times. Some, let's say woman is there, right? So is the woman pregnant? This is one feature. So if woman is pregnant, it will create some pattern. Is the glucose like a plasma glucose is there in the right in last 2 hours? So patient has taken or not, or what is the reading of that? So this kind of the blood pressure is how much blood pressure, what is the skin thickness they have, what is the insulin level they have. Right, these kind of the data set gathered. BMI index is there, diabetes pedigree is there, what is the age of that, and outcome. Based on the pattern they are deciding. 0 is not patient contain not a diabetes, and 1 is contain the patient diabetes, right? So this data set we have, so I will execute this. So here you can see that I use all the libraries, right? Pandas, NumPy, Matplotlib, Seaborn, right? So I will execute. So this is all library which are useful to perform the machine learning processes, right? Here you can see that the data set I just put online, so we can directly read automatically. These are the column. Label column is our Y, and these are all our X, right? So once it will execute, we will execute the second column. So here you can see that I read this data set, okay, with the help of PD. PD is nothing but the panda. So I will execute that, and you can just see like this. These are the data. So these data contain the 768 records and 9 columns. So from that 9 columns, 8 columns are the X and 1 column is a Y. Okay, now you want to know the information about this. So you stored this data into the PIMA variable. Now we want to check what is the information of that variable. So variable contain the different kind of information. So every column contains some value. So here you can see that every column contains the numeric value, but yeah, that is not only the numeric value computer is identifying. Inside the numeric, we are categorized into the float and numeric. So here you can see that when we got the fraction value, it considered as a float. So you can see that that column is a pedigree and the BMI that contain the floating value, right? So this is the information. Then after, over here you can see the not null count. So let's say some values contain the zero or none information. None is means nothing is there. Okay, and so this is showcasing like how much null value you have. Okay, so let's say 760 column is a 760 record is there on that column, but 8 record is blank. So that is known as a null value. Okay, and you can see that we don't have any null value over here. Now we want to check manually, it's like how many null values there. So this is a command. This is a data set, is null is a function you are just applying on your table, and after sum, so it will calculating how much null value you have. Then after, we are checking the target. Okay, so here you can see that we are using the histo, right? So here we are using a box, plt.box. Box plot. So whenever we are applying plt.box plot, it is not performed in box. Okay. Let's see, like it will plot the plot for us or not. Oh, it will not plotting. Okay, let's see over here only. So here you can see that they have plotted histogram. So histogram is like what is the severity of that patient, because obviously whenever we are predicting the labels, it is give us in the probability. But they have considered that 0.5 is a threshold value. So when it's above the 0.5, we consider 1, and when it is less than 14, 0.5, we consider 0. Okay, so that's why we have a more samples of 0, which is contain the negative. Sorry, like a patient don't have the diabetes and the patient have the diabetes, right? So same, you can see that positive and negative, right? So this is a count of positive and negative. Now we want to check that how many how many women are pregnant and what is the distribution of that. Okay, so on an average 3 women, right? So 3 women are pregnant from the diabetes, who have a diabetes and who also don't have a diabetes, right? So on an average 3 women is there. Okay, this way we can just measure the pregnancy data. Like this is nothing but the density curve. Same way we are measured the two label. So the woman who have a pregnancy and contain the diabetes. So whenever we are execute this plot, it is giving the graph like that, right? So this kind of the multiple graphs we are executing. Once you know that, we want to check like which column is useful. So I told you, right, we are not using all the features to train the model. Okay, so here this is known as a correlation matrix. Correlation is like how x is correlated to y. So here y is our label, right? Here you are able to draw the box. You are able to see this is our y. Okay, and now all other boxes are your x. These are the boxes is your x. Now you want to check the correlation, right? So how you can check it out? You are checking that when woman is pregnant, how its impact. So correlation is, let's say you have a correlation 1 between pregnancy and labor. That means if pregnancy is there, there is a high chance of the diabetes. Okay, so this way we can just measure the correlation matrix. So correlation contains the 3 type of the value: 1, 0 and -1. So these values lie between them. So when you have a positive correlation, so we can say it's nearest to 1, which is more good. So that means we can use this column to predict this label. Okay, same way, let's say glucose is there, so there is a 0.47. 0.47 is also considered the good compared to others, so we are using that column as well. So this is, let's say, blood pressure, which is not good at all, so we are not using. Same with skin, which is not good, we are not using. Let's say 0.13 insulin level, so we are using, because these are contained 29%, 70%, 24% compared to very less numbers, right? Because we have to use some columns, so that's why we are taking the 5 to 6 columns. Okay, so basis on the analysis, I taken some columns. Okay, I taken some columns, and you can see that I taken the 6 columns, say 6 to 7 columns, and I just define that 6 column for X and label column for Y. So this way we can convert that. Okay, and I also showcase you the diagram where we are just putting the data on training and testing. For that we have a function train test split, so we are using a 70-30. Okay, so we have to just 30%. 0.3 means 30% we are giving to testing data set. So whenever we are putting over here, it is just split the data set on training and testing. Okay, so whenever you want to check, let's say we have a 768 data, right? You want to check like how many rows are there in train, so we have to type save 0, x train save 0. So it is showcasing the 537 rows they have taken for training, and x test yeah, this is for testing. So whenever you just do the sum, it's contain the 768. You can see 527 336, and so this is for testing data. Now it's a time to define the algorithm decision tree. Okay, so I already told you scikit-learn, right? So you can see that this is a scikit-learn. We are using this module tree, and inside that tree we have a decision tree. Okay, so we are using these one to train the model decision tree, right? So we have already imported that. Now we will call it, right? So this is a class-based method. So we define the object. Once object is there, we are using a feat method, and we are putting this train data, x train, y train over there. Okay, so it is train the model, and after training the model, we are using this model to predict the data. So prediction we want on the test data, right? So we are using x test, and we so I will put on the training. So yeah, you can see that our data is trained. Now we want to check the accuracy, how much accuracy of this model contain. So we have a matrix accuracy score. So you have to take this data and you have to take y test. Okay, so this is our test data, y test, for validation purpose, and this is our prediction data which we have generated from these x test by training the model. So we have to compare these two data. Okay, so we are using that y test and y pred. Okay, so once we will train that, we want to measure the accuracy of the performance. Okay, so for that we are just putting, and you can see that it is contain the 68% of accuracy, 67.9, so 68% of accuracy. Okay, and now you want to see how these decision trees look like, right? So this model is trained on the accuracy, so we can say that 70% accuracy is average, or mostly say above the 70% is considered as a good accuracy. Okay, so here we had taken a default model, so that's now you want to generate the decision tree output. So how decision trees look like? Okay, maybe there is some error, but I don't know, maybe it will help to us or not. External. Okay, so this decision tree is depend on the string IO, but right now it is telling that they want the string IO variable. Okay, but we can code like this. Okay, we use that. We are putting on the graph visualization by our variables. We are putting the dot data, which is also the generate the image, and this is a kind of special features that you want to use to give it over here. And label, class label is like 0 means positive or negative. For that you can save that in a particular diabetes.png image, and your image is looking like this. You can zoom out that as well. You can zoom out on this level, like what is the calculation. So you can see that how complex it is. So for not taking calculation manually, we are trained this kind of the model, right? You can see that the how big it is. Okay, so this is your decision tree. So in decision tree, your all the leaves node is known as your output labels, right? Your all the leaves, right, of your decision tree is your target output labels. It will all the leaves giving you the target value. Okay, and all your root nodes are the features. These all root your node are the features and trying to generating the rule. So decision tree is nothing but the rule based machine learning methods. Okay, rule engine, you can say that. Okay, when we click down, you can see that this is the first decision tree, second, third. So every decision tree generate the subtrees, right? So this way decision tree is trained. And whenever you want to just check the advanced performance of the model, we are generating the classification report. I told you, right? Whenever we have a classification, we generate the precision, recall, F1 score. So for that, we have a function, classification report, confusion matrix, and accuracy. So we are generating like this. So whenever it's near to one, precision is near to one, recall is near to one, your model is performing good, we can say. Okay, and that way we are identifying. And we are also predicting the confusion matrix. So here CM is not defined.